Assalamu alaikum, this is RUBAYAT HYDER, matrix A17CS5335. I will be explaining regression analysis using MS Excel with the given data set already provided to us. To begin with, regression analysis is used to predict change in an independent value depending on a dependent value. However, this is an estimate because we do not because it's not an exact plot and it does not follow an exact equation. Therefore, we make an estimate of what the value might be. In the given data set, we have house price against square feet, which is the size. Now, we were given in the data set that the house price was in the y-axis, which basically tells us that it is an independent value. Alright. And now we have to choose the value of x's. Now, in our case, these are the values of x's. And this is what we want to find. This is our independent value. So we select this simply by dragging. Okay, and now we want to select the values of y's, which are these. We select these, and okay. Now we have a general scatter plot. As you can see, the values don't exactly they're not exactly linear, but you do see that they do follow a trend. So we can draw a trend line and show you exactly how this looks like. Let's do that. Trend line. I'm going to change how it looks. Okay, and this should give a clearer view. I wonder. Oh, never mind. So this should give a clearer view. I'll zoom in. As you can see, this does follow a linear pattern. This was because we drew the trend line, and this is the linear pattern it seems to be following. It doesn't exactly cut through all the lines. It does cut through a few of them, and it does seem to follow a basic trend. And this is we're doing a simple linear regression, therefore we're going to be going with the simple linear trend line. All right, so now what we want is we want to find the values. We want to find the regression for this. We want to find the general equation of this line right here. That's what we want. We want to find the intersect. We want to find the slope or gradient, and we want to find up to how much this should be correct. Right. So we simply go to more options. I clicked on this, so this should give us more options. And as you can see here, we have a bunch of things we could do. We could find a polynomial function for this. For the regression, we could find logarithmic, exponential, and whatnot. But for now, we're going to stick with a simple linear regression. So display equation on chart and display r squared value on chart. Now this r squared value is basically giving us till how much this is dependable. This is basically giving us telling us the probability of how much this is reliable. Right, so let's cross that out, and here we go. This is our value right here. That should be clear. And this is the equation basically, which is, as you can see, this follows a basic equation of y equal to mx plus c, m being the gradient and c being the intercept. So our gradient or slope is 0.1098. As we already know, the gradient tells us the change in y depending on the change in x. So we can expect for 1 square feet change of x, we're supposed to have a 0.1098 change in y, right? And this r squared value is giving us till how much percentage the probability of it being right is. On the other hand, we have the y-intercept. This basically tells us the value it would be given that the value of x equal to 0, which basically means given that there is no space which is in square feet, the x value is 0, what should be the value of what should be the price? Now, as you can already guess, there is some error here, which is obviously for 0 price there should be 0 space, there should be no price. However, as we can see, there is a 98.28 as a price, which is inaccurate, but again, this is an estimate and we're expecting it to be 0.5808 or 58.08% accurate. Now, there is another method that is a bit more descriptive, to say the least, in order to show regression. And in order to do that, first we need to go to File, Options, and we need to add an add-in. Option is right here, and this is what we want. Analysis toolpack. Go add the analysis toolpack. Okay. Alright, now we should have this new block, which is analysis, for data analysis. We select that and we want regression. So there are a bunch of other things that we could do, but for now, regression, and this means simple linear regression. Okay, and now we have to select the y input range, which is this, and the x input range, which is this. Now I want to select an output range, so let me just select one in random. I'll select this place, and given that I had selected the labels, I would have ticked on this, and there are a bunch of other options that I could use, but for now this is enough. And okay, and what we have over here is the summary output for the regression statistics, ANOVA, and coefficient. Now we're not going to look into all of these, but we are interested in some of these factors. So I'll pull this right here, sorry. So this is easier to notice. Let's zoom in. And what we have here is, what we want to look at is, first of all, the observation. And as you can see, the observation shows 10 inputs, 10 data sets, and you could count, and this is 10 data sets. On the other hand, we have R squared, which is the percentage. This is the same as this value. This goes into a bit more, like one significant figure more. However, it is 0.5808 or 5808. Now, what we also want to look at the intercept. Over here, the intercept is 98.2483, which is the same as 98.248. So let's mark that, and we have the x variable, which again is the same, which is 0.10977, which is a rough estimate of 0.1098, and this x variable is our slope or gradient. So this is the change in y depending on a change of 1, our unit change in x. So what we have over here is a rough estimate of what the value should be, or we are trying to predict the change depending on the increase in depending on a change in the independent value, which is the size. Therefore, we can determine, and we have created a basic formula for this change. However, this is far from perfect, but this does give us a 58.08% accuracy. That is it for the explanation of regression, simple linear regression analysis using Microsoft Excel. I hope I was clear on this. Thank you.